In this video we're going to take a look at the Naughty or Nice challenge from the recent HackTheBox Cyber Santa capture flag competition. If you haven't seen already, I did videos for the first 4 days of the competition, so there was a challenge from each category released each day. But when it came to day 5, we only had like a quarter of the amount of time to solve the 5 challenges, and the difficulty had been stepped up quite a bit, so I actually only got the web challenge finished before the competition ended, so that's what I'm going to run through now. But I might do some of the other challenges as well, some of the other day 5 challenges, we'll see how it goes. Anyway, the description for this one says, all the Santa's nice elves have been added to the naughty list by the wicked elves and Santa is mad. He asks you to hack into the admin account of the Naughty or Nice portal and retrieve the magic flag that will let Santa finally banish the evil elves from the North Pole. Again, we've got some files to download here and we've got a server to connect to. I'm just going to go through this as I kind of solve the challenge, so I didn't jump straight into the source code. I went to play around with the functionality first of all, see if I could identify what area we need to focus on, and then whenever I got stuck I went and had a look through the code to try and see exactly what the vulnerability was. So yeah, let's go through it in that order. Let's take a look at the site first of all. So in the center of our screen here we've got this card, which if we highlight it, it's got a hand instead of a normal cursor, and if we click on that we can open up the nice list and the naughty list with a list of the elf names in there. No other functionality that we've got there at the moment, but it's worth bearing in mind. We don't really need to look at the source code here because we've got access to the full source for the server side as well. So let's just go and try to log in. We've got this login form, enter a username and a password. Let's just try the usual admin, and we get invalid username or password. Let's try our standard kind of SQL injection then. So I'm just going to make this a bit more visible. Get rid of that password type so that it shows the data. And we can do something like, or try that out just to see if we've got an easy SQL injection. We don't. We could also go and try to see if there's some kind of blind SQLi here. We can take a copy of the post request and go and just put this in a file, new.request, or you can call it whatever you want. We'll feed this into SQLMap. So we can pass in new.request, just hit yes for all the default options. I'm just going to try for various blind SQL injection types. It doesn't find anything on either of the 2 parameters there. So it says we could try some other things. We could try tamper space to comment, or we could use a random user agent, or we could increase the level of the risk. I did try to increase the level, I think, and do the tampered space, but there was no change anyway. So let's go and see what else we can do here. We've got an option to create an account. So let's try to create an account. I normally just try to create one with admin. Note that as soon as I put in admin there, it came back with a red box. I don't know. Okay, let's try it anyway. Admin, we try to create, we get username already registered. It seemed like it was checking the username on the fly there, but maybe not, because whenever I put in another username it's still red. Alright, so we'll just do something else. Just say admin1 instead. Create the account and we'll try to log in. Admin1 and admin. The reason I put that to admin1 rather than like CryptoCat or something like that is dependent. We don't know what the vulnerability is here yet, but there could be something whereby we only need to say if the username is encrypted into a cookie. If we just have one character that's different to the admin user, there might be some kind of like pad busting attack or something you can do there. But we get in anyway. It says access denied, you shall not pass, and the only option we have is to log out. Have a look at the source code. Nothing of interest, but we can go and have a look at the source code in more detail in a second anyway. Let's also have a look to see if it created a cookie. Have a look at our storage here, and it did. It looks like a JSON Web Token, so we can put that into Burp Suite, into the JSON Web Token converter. Oh, didn't get the whole thing. You can also take it to something like JWT.io as well. I'll actually just show that briefly. But you can see here it's showed us the headers, the algorithm that's being used, and then we can see the payload as well. So we've got our username, we've got a public key in here, and then I guess the initial access time or something, and then we've got the signature here. So see here, invalid signature, wrong key, claim failed. Let's go over to JWT.io as well. We can insert this here. Same information. We can go and basically go and try it. You can see it says invalid signature at the moment. So if we were going to go to try and update this to admin, we would need to make sure we have the keys here in order to make sure it will be validated properly. We can't just change this to admin, base64 encode it again and expect it to work. But we can go and have a look and see what type of vulnerabilities exist. Let's go to Nunjucks JWT. And you can see here then we've got a range of options down the right hand side here of potential attacks that we might be able to run on it. And the first thing is here we've got this JWT tool, which is recommended as a tool which you can just kind of run various tests on to see what kind of vulnerabilities there might be with the JSON Web Token. You can also use it for tampering and stuff like that as well. You can see here modifying without changing anything. We can try and change the algorithm. So for example, change the algorithm to none instead of, I think it was RS256. So we could try and change it to none, or we could try and change it to HS256 or something else. As you can see here, change the algorithm. And the reason for this being the algorithm HS256 uses a secret key to sign and verify each message. RS256 uses a private key to sign the message and a public key for authentication. If you change from RS256 to HS256, the backend code uses the public key as a secret key and then uses the HS256 algorithm to verify the signature. Then, using the public key and changing RS256 to HS256, we could create a valid signature. So that sounds interesting just because we know that it is using RS256. But let's go and check out this JWT tool and see what we can do with it. You can see it will test for a variety of known exploits. See the CVEs here, and this is kind of what was mentioned there, the swapping between the two algorithms, changing the algorithm to none. We can also potentially crack secret keys and stuff on depending on the algorithm used. But let's download this and test it out. So we'll do git clone. Make sure you've got all of these Python packages installed. We've got our usage here. We can also provide a URL, so we can actually go and test URLs if they provide a JSON Web Token, for example. Common workflow, so it gives a suggestion of how to approach a challenge. So if you come across a challenge like this, where you see a JSON Web Token, download this tool and just follow this. Do some recon, do some scanning. If you find something, do some exploitation, some fuzzing, some review. And you've got a general methodology that you can follow here. Let's go and try this out. Let me take a copy of our JSON Web Token. Let's go into the JWT tool. We've got our Python JWT tool script to run. We run that, we get some, okay, it doesn't, there we go, we get some options of how we can use it. We can give a URL as we mentioned before. In this case, I'm just going to provide the JSON Web Token and just see what we get from doing that. So it comes back with the current values in the header and the payload, and that's about it. It didn't give us any. Okay, it didn't give us anything else. Let's have a look at the help menu again. Bring up the help menu. We can use exploit, so -X, and then we can specify, do we want to try it with the no algorithm, do we want to try null signature, do we want to try and spoof, we want to do some key confusion, specify public key with PK. Okay, that's interesting. Let's try and run that with -X. I think you can do -X A to run all, is it? Or, oh no, that'll do alg none. Alright, let's try it with none anyway. -XA. Okay, so it gives us some different signatures here. Okay, no, they all look like the same signature, but we'll go and try it anyway. Just go and update this in the cookie in your developer tools. You can also just do it through Burp Suite as well. So if we go to our proxy tab here and select one of these requests, you see we have a lot of Firefox settings attached stuff here, and then some stuff to Google APIs, GitHub, stuff that we're not going to be interested in for doing this challenge, by the way. So you can just go ahead and select the challenge URL here, right click it and go add to scope. And then you can see a scope here, go into target, scope, and okay, we want to change that slightly because that's only gonna, it's considering the directory as a scope as well. Let's just set the scope to be this URL. Let me remove that. I don't know why I have, oh, do not delete. Okay, I'll not delete it. Alright, so we go back here. We've still got a lot of stuff in our HTTP history. If you want to get rid of that, just click this filter and say show only in scope items, apply, and now the only thing we're going to see is stuff that's going to and from this URL. So we're not going to see any hack tricks or GitHub or HackTheBox stuff. We're only going to see this challenge. Alright, and that means that whenever you are sending stuff here, this should have there's our JSON Web Token here. So you can intercept requests and just basically update the JSON Web Token here as well to test this out. For example, we have this get dashboard, so let's send that to our repeater. And then in the repeater we could just go and update our JSON Web Token here, so we'll grab this one. We'll grab that, we'll replace this here, we'll send it off, and we've got, okay, we need to follow the redirection here, follow the redirection. Yeah, alright. You could right click this then and open in browser or request, show response in browser. I think by this stage it's probably better off just modifying it through the developer tools. Alright, just forget this. So the JSON Web Token didn't work anyway. It took us back to the login page and it actually deleted our token. So we could add a new token here. We can just add a token and just change this to session. And we could put in our JSON Web Token. Actually, let's put in our original one. So this is the unmodified one. Refresh the page. Okay, that didn't log us in. Alright. Well, that's fine. I'm going to log in again. We don't really need to, but... Okay, and next up we're going to want to try some of these other attacks then. For example, this one seemed to be of interest. I am just going to go and have a quick look at the code here. Not necessarily needed, but let's just go and try and understand a bit more what's going on in the background. This JWT tool, I shouldn't really have put that in the same directory. Let's have a look at our server code. So we've got a build Docker script. If we want to run this locally, we can do. Our flag is going to be here as well, so we know this is how we're going to try to retrieve our flag. It's going to be one directory up from our challenge. And if we go and have a look at our challenge, let's see if we've got anything in supervisor. No, okay. Go and have a look at our challenge. We've got a database.js here, which is always interesting. We can see the username and password has been put in here of the admin and the admin password, which we don't know. We've got elves being put into the nice or naughty. And we've got some functions here to register where the username and the password will be put into the database. We've got a login where it's going to grab the username and the password. So this is where we were testing for that SQL injection. Although there was SQL injection on one of the earlier web challenges in this competition, so it could be reused, but it's unlikely to see the same vulnerability come up again. And we've got get user and then list names where it's going to select all from nice or naughty, and then edit name as well. So this select all from nice or naughty is probably back to our home page where we had the card filled with those elves. And then we also have this edit, which I didn't see an option for. Have a look at the index.js here, nothing of interest. Note that it's using some of the things it's using here, so we've got Nunjucks, we've got cookie parser, so maybe there's some vulnerabilities in some of these libraries. Let's go and have a look at our pages. We've got admin, we've got card, we've got dashboard, login, register, and settings. Update account information. This isn't an option that I've seen so far. And obviously the admin we're not going to be able to access. Let's go and have a look at the roots. Immediately notice that it's using these helpers, so we're going to take a look at those in a second, the JSON Web Token helper and the card helper. We can make a GET request on the home page, which is we've got this card generator, we're going to have a look at that in a second, but it's basically going to print out all those naughty and nice elves on that card that we looked at. We've got a login, we've got a register, which we've looked at, we've got a dashboard, which is where we are at the moment. We've got this API elf list. Note that if we try to call this, try to make a GET request, it says here if the username is not admin, it's going to say response denied. So if we go and try and enter that, access denied, yep. Okay, so we need to be admin in order to get to the elf list, and we also need to be admin in order to edit an elf. So we'll have a look at those in more detail first. Sorry, not first, later. Because obviously we first need to make sure that we're admin before any of those functions are going to be of any interest. Although, let's just go and have a quick look and see what this was doing here, the generate card. This is part of this helper. So we've got a JSON Web Token helper. We've got a card helper. The card helper is loading the elves in the elf list, printing out all the elves which are naughty or nice. Then it's going to create this card, and then it's calling resolve nunchucks.renderString. So this is interesting. We'll have a look at it later though. Just bear that in mind, and let's have a look at the JSON Web Token helper. Okay, so we can see here that for sign in the JSON Web Tokens, it's going to use the RS256 algorithm, and for verifying, it has either algorithm specified, so it should be using RS256 for both of these. But for some reason, they are saying that you can also use HS256. It will be accepted. So that vulnerability that we were looking at there sounds like it's quite plausible, because we know that our JSON Web Token, let's go back to burp, has this public key in it, and it's telling us that using the public key and changing from RS256 to HS256, we could create a valid signature. So maybe we can do that, and we can go and modify the username from admin1 to admin, and swap the algorithm and use our public key to sign it, and see if that'll give us admin access. Okay, first things first, we're going to want to save that public key. So, I don't still have the JWT.io open. Let's get it from Burp Suite. I think it was in a slightly better format, but this is fine as well. So, okay, it's really not fine. Alright, I'll copy it like this, and then we'll just modify it a bit. So, we're going to call this key.pub. Paste this in here, and we want to just separate this out, so we've only got the public key. We want to change these new lines into actual new lines, so I'm going to do Control and H for find and replace. We'll replace new lines with new lines, but I'm using the regex mode here, so we just need to escape this \n here. You can see it's now matched those. We'll hit replace all, and we've got our key. One thing to mention, make sure you don't have a new line at the end here. I did have a new line whenever I was trying to solve this, because I know with the SSH keys you get some problems if there isn't a new line quite often at the end. Alright, well that's that created anyway, so let's try and run Python JWT tool. Let's grab our original token, and we can, let me bring up the help again. So we're going to want to sign this. We're going to change the algorithm it's signed with, and it's telling us that we're going to want to specify a key. So we're going to be changing this to HS256. We'll try the HMAC SHA sign-in, and we also want to tamper with it. So we want to go and modify the name. So let's try and run -s h256. It's the sign-in algorithm we want to use. -k for key public. Oh, it's not doing autocomplete with that. Alright, key.pub, and then -t because we want to tamper. And we're at the header here. It's asking us, do we want to update any of these header values? We do. We want to change the algorithm to HS256. Hopefully that doesn't matter if it's case sensitive. I'm assuming it doesn't. Continue to the next step. We've got our payload, and we want to change the username from admin1 to admin. So we'll put in here admin. 0 to continue. It prints out our tampered token using HMAC sign-in. So we'll go back to the Naughty or Nice portal, we'll hit F12, we'll replace our session cookie and refresh the page. And we're taken through to this new dashboard which has a list of these elves showing that these ones are all naughty, and we finally have the option to edit them. Okay, so now that we've got through this part, we can go back to our code and have a look at this cardhelper.js. Remember I mentioned this Nunjucks and the render string was interesting. This is a type of vulnerability known as server-side template injection. Let's search here SSTI, get a list of payloads that we can test out here. You can see down the side there are various different languages. Some of them are PHP, Python, Java, JavaScript, and in terms of the vulnerability here, Portswigger's resources are always great for checking this stuff out. So you've got labs, and you have kind of just guides and cheat sheets as well for like XSS and SQLi and stuff like that. So if you want to learn about SSTI in more detail, go and read through this. There's no point me just reading through the whole thing. But in general, A server-side template injection occurs when an attacker is able to use native template syntax to inject a malicious payload into a template, which is then executed server-side. So let's go and have a look at some general syntax here. It will vary from language to language, but quite often something like this will give you an idea. So depending how this comes back will depend what language is being used. So for example, in some cases, if you do like 7 times and then the text 7, it'll come back with 77777, and in other languages, whenever you do that, it'll come back with 49. So this is normally one of the first things that I would try here. So we'll go and update the name to 7 times 7 insert inside these curly braces. But we don't get back any. We're expecting this to execute and bring back 49, which it doesn't. So I was a little bit confused about this for a while, and I had to go back and review the code at the time. If we go and have a look at, is it the elf list? Okay, so I think this is what's being called at the moment. It's just calling elf list. Let's have a look at the proxy. Yeah, API elf list. So this is just calling get elf list, and note that whenever that's called, it's not actually doing anything with the. It's not calling render template or render string or whatever was being called. If we go back to our card helper, this is on the generate card. Render string, and this was the card that we saw at the beginning. So let's go and open up another page, and let's, not the dashboard, let's go back to the home page, let's click on our card, and we've got this elf on the naughty list called 49. So the 7 times 7 that we've entered has been executed and it's brought back 49. So that's great, we know we've got code execution here. What we want to do is go and find a payload that's specific to Nunjucks, which is going to be able to either get us a shell or retrieve the flag or do something like that. So we'll just search here, Nunjucks SSTI. You can search SSTI payloads, something like that. You'll find a couple of articles here about specifically with Nunjucks. Actually, whenever I search this, it's always funny how the different results I get with Google. Let's go back. We go back to Google and we've got one from John Hammond there, so there's a previous HackTheBox challenge which had Nunjucks template injection, so we could go and have a look at that. What I was specifically thinking about there was one of XDF's walkthroughs for a HackTheBox machine. Let me try and grab it. So these walkthroughs for HackTheBox machines, in my opinion, are the best write-ups that you'll find. If you like watching videos for HackTheBox machines, then you've got IPSec. If you like watching videos and you've got very little time, then you've got XCT. And if you like write-ups, you've got XDFs. Although XDF has been doing some YouTube videos recently as well, which I'd recommend checking out. So some of the run code challenges and stuff, which were less focused on security and more just general kind of programming, although I think there's been some security style walkthroughs as well. But yeah, let's go and have a look and see what payload they used in this example. You can see they did the same thing, 7 times 7 is 49. And then they found an article, this post here, which is actually, yeah, this is the one that I already had up as well. So you can go and have a read through this and see how they put the payload together. I actually just grabbed it from XDF's guide, so let's go and submit this as the name. Let's try to reload this card. Okay, need to refresh the page, I guess. There we go. Alright, so the card is now showing and now has the etc password file being displayed, so that's great. We've got execution. Let's go and try and modify the command a little bit. So here we can say ls ... We'll refresh the page again. We can see flag.txt is there, so one last time we can update our command and say cat, oh, missing a quote, cat ... flag.txt. Refresh the page. Oh, something went wrong. I've got too many quotes in there. And it's in the wrong place as well. Or is it? Maybe that was a double quote there. Double quote there, and then a single quote. Try that again. Looking better. And there we've got our flag. You can't see it very well, so you might want to go to inspect the element, and then you can grab it from here. But that's this challenge solved. A final reminder as well that there will be a live stream from HackTheBox on the 14th of December, going through some of the challenges from the competition with lots of awesome creators, so definitely check that out. I'm not too sure if I'll do any more videos from this CTF, but we'll see. And if you have any questions or comments, leave them down below. Thanks.